n dot sigma and n dot sigma dot n, two terms of foundational importance in fluid mechanics. N dot sigma is the stress that acts on a plane, and n dot sigma dot n is the normal stress that acts on the plane. The problem is, how do these combinations of n and sigma come to mean what they mean? Watch until the end and you'll be super clear on the physical meanings of these two dot products of n and sigma. In fluid mechanics and transport phenomena, you will frequently come across the stress tensor sigma in combination with certain quantities or variables. Here are the 7 key terms that involve sigma. Let's dive into the physical meanings of these terms one by one, from easy to difficult. The first term coming up for discussion is the most basic term, n dot sigma. Suppose the fluid is flowing within the confined space of two solid boundaries. We want to find the stress that acts on each surface of a cubic fluid element. The stress acting on each surface can be decomposed to 3 components, leading to a total of 9 components. These 9 components make up the stress tensor. The stress vector on the x-plane, denoted as SEX, is equal to EX dot sigma, which is equal to the sum of the 3 component stresses on that plane. The stress vector on the y-plane is equal to EY dot sigma, which again can be expressed as a sum of 3 component stresses. The same analysis can be applied for the stress vector on the z-plane. In general, the stress vector on any arbitrary plane with the unit normal n is n dot sigma. The arbitrary plane means it can have any orientation, like this or this. It's interesting to note that the first row of the stress tensor contains the stresses that act on the x-plane, whereas the second row contains the stresses in the y-plane, while the third row contains the stresses on the z-plane. In the following discussion, the plane that has the unit normal n will be referred to as n-plane. Here is an example question. The stress at point P in a liquid flow system can be described by this stress tensor sigma. Calculate the stress vector at point P on the plane with the unit normal n. We know that n dot sigma is the answer. Proceeding in this way, we can get the answer easily just by plugging in the numbers. This is a possible visualization of the problem. In a nutshell, n dot sigma is the stress vector that acts on the plane with the unit normal vector n. The next term coming up for discussion is n dot sigma dot n. Before we continue, if you find this video helpful, I hope you can support this channel by hitting the like and share buttons. Thank you. Making such intuitively animated educational videos is not easy. It takes a lot of time, effort, patience, and motivation. Each animated scene has gone through a lot of testing and modifications before appearing in its final pleasing form on screen.
Let's continue.
We'll use the same example as before. We already know that for this problem, the stress vector that acts on the n-plane is n dot sigma. This stress vector can be decomposed to 3 components, 1 normal component and 2 tangential components. For real understanding, let's make it visual. From this picture, we can see that the projection of the stress vector n dot sigma in the n direction is n dot sigma dot n bracket n, where n dot sigma dot n indicates the magnitude and n indicates the direction. The projection of the stress vector n dot sigma in the t1 direction is n dot sigma dot t1 bracket t1, where n dot sigma dot t1 is the magnitude and t1 is the direction. Similar analysis can be applied to the t2 tangential component. I want to highlight the relationship between n dot sigma and n dot sigma dot n. This red box shows the mathematical description, and the right side diagram gives the corresponding visual description. In the term n dot sigma dot n, n can be a unit vector in any direction. We now look at some interesting cases where n is equal to the unit vectors in the x, y, and z directions, which are Ex, Ey, and Ez, respectively. Ey dot sigma dot Ey means the magnitude of the normal component of the stress vector Ey dot sigma. From the stress tensor diagram, it's clear that the answer is sigma Yy. Similarly, from this diagram, we can see that ex dot sigma dot ex is equal to sigma xx and ez dot sigma dot ez is equal to sigma zz. This is the same example as before, but now it asks a different thing. It asks about the normal stress at point P. We bring back this picture from the previous example, and we can see that the question is in essence asking for the stress in the n direction. The total stress acting on the n plane is Sn equal to n dot sigma. The normal stress acting on the n plane at point P is equal to the normal component of the total stress acting at point P. Plugging in the numbers into this equation, and we are done. In a nutshell, n dot sigma dot n is the magnitude of the normal component of the stress vector n dot sigma. The next term coming up for discussion is the surface integral of n dot sigma. That's all my story this time. I hope you enjoyed this video and have now become crystal clear on the physical meanings of n dot sigma and n dot sigma dot n. Don't forget to hit the like and share buttons. Consider subscribe also if you want more of such intuitively animated educational videos from my channel. If you are new to stress tensor, you might want to watch this video to gain some very fundamental basics on stress tensor. I'm Kyle Tan. See you in my next video.